Hi, my name is Charles Payne. I'm here with the CEO, Jose from Plexicus. Hello, Jose. How are you doing today?
Hi, I'm very good. Thank you for inviting me here.
My pleasure. So, a little bit about myself. We all know I'm the CISO CTO for Neptune Media, and we host the Horizon Summit, which is why everybody's watching the podcast. Can you tell us a little bit about yourself, Jose? Maybe about how you got to be the CEO and maybe some of the other things that led to the company formation?
Okay. Actually, I've been working in cybersecurity for the last 20 years. I'm based in Madrid, but I've been working in not only Europe but also in US. And in the past, I had different uh, entrepreneurships. My previous startup was DynoFlags. It was a threat intelligence platform that was acquired by Telefonica in 2018. Now I'm starting a new startup, Plexicus. Actually, we started last year in the last quarter, but we already have some prototypes and MVP. So what we do is we are focusing in code remediation using AI, and basically we are starting to test the market.
Terrific. So you say code remediation. Let's dive a
Yeah.
little bit more into that. So when we talk about code, we're talking about maybe like a GitHub repository or maybe like an Azure repository for like a CI/CD pipeline.
Yeah, actually, why code? Code because I think sometimes it's really hard to fix issues in code. The average time for fixing an issue is around 2 months, but this is the average. In the worst cases, according Vera Code report from a couple of years ago, it used to take more than 1 year and a half to fix 20% of the vulnerabilities affecting the companies. So what we are doing is we are not doing another SAST. Actually, we integrate other SAST. You can name it other. It can be 45, check marks, wherever. We have 41 integrations. So once you provide the report from the SAST and the repository, what we are doing is analyzing all the vulnerabilities. We can do something that is great, is we can detect false positives. So we will discard a lot of vulnerabilities. But the other thing is we also have an algorithm to prioritize the most important vulnerabilities. So the first thing we do is we discard the false positive, then we focus in the most critical vulnerabilities, and we don't use the regular uh, uh, way to short them. So we don't use the criticity, I mean, from critical, high, medium, and low. What we do is we focus on the exploitability. For example, sometimes in code, you can find vulnerabilities that is really a vulnerability, but it's not exploitable. So for us, this is even the impact could be very high, as it's not possible to exploit it. For us, it's not important, and we will never prioritize it uh, uh, because of that. So once we have the information about all the vulnerabilities we want to start for the remediation, what we do is we use our AI platform. Actually, we are using LLMs systems. So we process the information from the SAST, for example, 45, and we can understand very well the context. The main problem of the SAST is that sometimes the report contains information regarding the vulnerability, for example, in PHP, but the customer has the solution, for example, in Java. Their application is written in Java. Is written in Java. So what we do, we can analyze everything and we can tailor a solution, a definition of the solution in that is very clear and is adapted to the customer. But not only that, we also can create the code that remediate the issue. So once the code is created, we can create a pull request, and the only thing the developer has to do is accept it if everything is okay. So this is basically the tool we have created.
They've actually used a tool, a SaaS tool, for their SBOMs and stuff to build that out. So then they have this as their purpose. So they've got that port of validation. But then, so essentially, what you do is you revalidate and you validate the results of another application that the customer is using in their environment. So it seems like you're actually saying, like, look, this software in the system says that this is vulnerable, but the probability of it actually being exploited is like 0, or maybe this is a false positive to begin with and it should be discarded. I've actually lived through this nightmare when I was dealing with Log4j. We had a security scanning tool. I won't mention any names. And it kept flagging everything that said anything to do with Log4j. So if it said Log4 in it, it would flag it as a vulnerable file. So it seems like your tool will actually go validate somebody else's report, and then it will come up with a solution of how to actually remediate something if it is not a false positive. And that's a pretty unique perspective. I've seen many times where they give us the opportunity to remediate using or LLM models or machine learning, and those are pretty unique. But it seems like your solution goes a lot further than that. It looks like it will will take into consideration the file from the SaaS tool. It will then validate and find out if that's even a false positive or if it's actually a legitimate concern. And then it will prioritize that concern based on if it's even exploitable in the environment. Because there's many times as a CISO, I notice that yes, we have files in our environment that are exploitable, um, but it's on a system that's not even connected to the public internet. Like it's not publicly accessible. Like it's only accessible by certain internal things with certain accounts, and that's if and only if they have a token to access it for whatever purpose. So it's like the probability, in essence, is it's air gapped. So in that regard, it's not a concern for us because the opportunity of somebody physically walking into our office to exploit it is going to be nil. So in
Yeah,
that regard, those aren't critical. Yes, there are critical vulnerabilities present, but in our case, since they have to be physically exploited, they've got to do it in person, and that's not going to be possible for anybody to exploit. So we've got to do that manually right now. It seems like your tool does it automatically through the way your process works. Are you able to speak a little bit more about? I know some of it's part of your proprietary model and your LLM, but maybe if we're able to talk about like how you might find or how you might come to like the known good or the best case scenario of how to remediate bad code.
in a perfect world, you will need to a cybersecurity expert may need to find to run the tool, then get results, then pick up one of them, then trying to understand if it's a real vulnerability or false positive. Uh, they need to do the um, validation of the vulnerability. Maybe they need to contact to the developers for discussing something. So in a perfect world, this may take around 5 hours. We have the calculation because in the past I used to do this kind of services also manually. So and it's not realistic doing this in 5 hours, but let's say it can take 5 hours. With all the process we have measured that we can do it in 5 minutes, and most of the time is the time that a human need to validate the solution from the AI. To your question, how we do for fixing the bad code? Okay, actually the process is the following: we take the information from the report, so the LLM is able to write code, but now also have the context of that vulnerability. So we're injecting that context so they can understand which is the file, what is the line, what is the problem, and everything. And we give also access to the Git repository. So one solution maybe needs more code, maybe needs to get more lines down, more lines up, maybe need to open another file. So the application will be asking and trying to fetch more files from the code, trying to analyze more files and for getting all the context and be able to fix the solution. But if the problem is in one single line, we never touch more than that. We focus in the problem and we apply the solution according to the report. Sometimes the report is not really accurate, as I said before. Maybe the solution is in PHP and the application is in Java. So this is a real problem when you're using SaaS tools in real world, because the programmer, maybe they know how to program in Java, but they don't know how to, maybe they cannot understand something in PHP, or maybe they do it in different way. So the good thing is the LLM can understand what is the purpose of the protection mechanism proposed by the SaaS tool, and it can apply directly to the code. And the only thing is, the only modified lines are the lines that are affected by the issue. We never touch anything else. And aside from that, there are three kinds of validations. Once we have a proposal for the remediation, the cybersecurity guy needs to give the approval. Then there is a developer that also needs to approve and send in the pull request. And also, obviously, there is someone that is accepting the pull request. So there are three humans verifying the whole process, because we don't think it's good, at least now, at this time, to make automate a pull request without human supervision.
Yeah, fair enough. So it sounds like you really, well, I mean, I'll speak from my own experience contextually about the company I was working with that had 300,000 devices. I mean, it took me months to actually remediate all of the issues, mostly because of, we're dealing with different time zones around the world, and then we've got a lot of other things going on. So if I could have found out what we needed to do in 5 minutes, it wouldn't have taken us 2 months to roll out all the solutions. It was a matter of trying to read the report that we got and then understanding what that report said, and then go back, because I don't have any way to validate if it's a false positive. I go audit and validate all of that, which is a waste of time, because 90+% of what they actually gave me was actually false positives. It was positives. It was files that didn't actually affect log4j. It was a file that was just named log4. We spent a great deal of those 2 months trying to validate and chase our tails for a while. And then, of course, it was log4j that was having an issue, and it actually had to be remediated 5 times, because they came out with like things like 217.1 and 217.2 and then 5 and whatever else, because they kept realizing that they didn't fix it the first time. Eventually, we figured out that we can just remove the single class file from the archive, and then we can mitigate the issue across the board, never have to worry about patching the file again, because we've removed the class that was vulnerable. Had someone told us that the first time, it wouldn't have taken us 2 months to complete the remediation process. The class file inside the archive that's vulnerable. It's the code of one of the submodules that's the vulnerability and the problem. And we were told initially that we could have just removed the subclass out of the log4j modules. It would have been completely beneficial. I mean, I can't remove log4j in our environment, because I'll break our environment. So I can't remove the file itself until we realized that we can remove the class file that was actually the vulnerability inside the archive of the code to remediate. So if we would have had like an easy button, if you will, to remove that, that would have been great. So it sounds like your tool is going to give us a little bit of that contextual purpose and that validation. So it seems like it's going to help, especially the enterprise levels, find out what's valid, find out what's false positives, give you some type of rating if it's going to even be exploitable in your environment, and then walk me through how to potentially even remove just the class instead of trying to update the file. If we were to remove the subclass from log4j initially, it would have never been exploitable to begin with. So had we been advised of that, or had we known that initially, it would have been a completely different conversation. It would have been a lot faster to remediate. We wouldn't have spent countless man hours to work on that. So it
Yeah,
sounds pretty interesting about how your tool contextually can see what we're doing, what our purposes are, and then really run us through the validation process.
yeah. Aside from all the advantages of using AI, for example, for understanding the reports and also creating a remediation, regarding false positive, we found really, really amazing results. Uh, there are the current SaaS tools. Some of them, they are great. They are able to rate the code, to create the links between the functions, so you know where is the source, you know also where is the sink. So they create the path, and they understand all the functions that are where the variables are passing through. But sometimes they cannot do something so easy like understanding the meaning of a comment in the software. For example, if you have a comment in your application with the password word, the SaaS tool, they are not able to understand that because they can understand the code, they can understand the flows. However, they cannot understand the natural language. So we found that we were able to detect a lot of false positives. For example, in this case, for detecting the password word in the comments. This is just an example, but I think we can find value of using this technology in different points of the development process.
So, and which different type of repositories do you guys integrate with? I'm assuming probably GitLabs, GitHub.
At the moment, we have integrations with GitHub. I think it will not be hard to integrate with other Git repositories like GitLab or Bitbucket. But the next step is integration with the former TFS from Microsoft. I think they rename it, but I cannot remember the name. The former name is TFS, and I think it's used for large organizations also aside from Git. So basically, we will keep these two main software version control systems.
Excellent. Yeah, I know we've used SVN, we've used a few others as well, but I normally tend to use Git or I'll use like the Azure version of Git just to make it easier because I try to always automate our CI/CD pipeline. It's always beneficial to make sure that everybody has the opportunity or the ability to see the code and we can see the workflows. So we all have the same, we're all on the same page. It's very important that I let the developers know like what the lifecycle is and what their expectations are because if they're waiting on a piece of code to be developed by one of the other folks, it's very important that they understand what their progress is. But at the same token, it gives them the opportunity to to work together, to cross-pollinate, because sometimes they might get stuck or they might not know how to do something specific, or maybe our security team wants something done specific, whereas the dev guy might not fully understand how to implement it in that specific way. And it gives us really the opportunity to really integrate both into the same thing. So I hate saying DevSecOps because it's kind of counterintuitive, but it gives our security teams the opportunity to integrate with our development teams at the same time to, at that point in time, cross-pollinate and really work together. It's that cross training, that cross unification between all the different departments that I found become quite successful. If I try to do it where they're in their own little silos, it's never beneficial. It never works correctly. And then the security team usually gets mad at the end because the development team just did whatever was fast and easy and they didn't take consideration of any of the vulnerabilities or the security implications moving forward. And that's where workflows at the same time so everybody knows the progress. So if you got something to say, if you see something, say something now. And I think that your tool would give us the opportunity to maybe see what we can do to automate it. So in that regard, if our SaaS tools or our DAS tools find something that's vulnerable, but I'm glad that your tool would then give me some type of contextual answer or some type of contextual based result of like, hey, look, this is wrong or not the best practices. Maybe you could consider doing it like this.
We really think that AI will be very helpful in all the cybersecurity ecosystem. That's why we have some plans for creating uh, other tools, other products that can help in this field in cybersecurity. For example, for infrastructure, managing incidents in a security operations center, for example.
Excellent. Well, I appreciate your time today, Jose. I know that you're very busy, and I know it's got to be late over in Madrid at the moment. So I do appreciate your time, and thank you very much for taking the time out to explain to us how your product works and why it's actually beneficial, and for having the conversation.
Thank you, Charles. It was a pleasure.
Thank you, Jose.